Hello! Today, let's talk about thermochem equations. So really, short lesson, all we want to understand is what thermochemical equations are and then how to actually read them and interpret them. Normal chemical equations you're used to is reactants and make products. When you have thermochem equations, think about the thermo component, think about heat. Now what we can start to express in our equations is the changes in heat as a result of the reaction. So that's why we call these thermochem equations. In thermochem equations, we're actually showing energy changes. So in thermochem equations, you're showing the energy changes that happen as a result of the reaction. So here, for example, ethanol reacts with oxygen to produce carbon dioxide and water. As a result of that, you can see this other component here. So you can see that this is a delta H. Now that just means a change in enthalpy. And as a result of the reaction, you have negative 1360 kilojoules. Now, so the negative here doesn't mean that you've got negative energy. What it is trying to show is whether or not energy is being released or it's being absorbed. If you've got a positive sign here in front of the energy value, then it's endothermic. If you've got a negative sign, which is what you've got up here, that means that you're releasing energy. So the way that you interpret this is you're saying, hey, as part of this reaction here, you're releasing 1,360 kilojoules of energy. Now, traditionally what VCAR wanted you to do was to have it expressed as kilojoules per mole. But what they've decided to do in the new syllabus is get rid of the mole, and they're just saying, hey, show how much energy is released as a result of the reaction. And so what that means is when you use 1 mole of ethanol and react it with 3 moles of oxygen to produce 2 moles of carbon dioxide and 3 moles of water, you will also release, as a result of the whole reaction, 1,360 kilojoules of energy. This energy value here is reflecting the balanced equation. So whatever mole ratio exists in your equation, that's the energy that's released from that. So here, for example, so if you translate this equation, it's saying for every 2 moles of ethane, so you can see it's a balanced equation, 2 moles, it will release 3,120. So you can see here it's negative again, which means there's a release in energy. So 3,120 kilojoules of energy. So if you only use 1 mole of ethane, as an example, you'll only release half of that. So now this here is also a part of your stoic ratio because it reflects the balanced equation. So what I'm trying to say here is now you can use stoic with energy values as well as your reactants and your products. The great thing about this, the enthalpy, right, is it's all in your data book. So any of the enthalpies that you need to know for the fuels that you need to know about, they're all here. And it also helps you to actually write a balanced equation. So you can see here, they've even given you the states. So a lot of my students will always ask, is it going to be gas? Is it going to be liquid? And traditionally, you have to think about, well, how much energy is released. They've actually told you at SLC conditions, if these reactions happen, the water is actually released as liquid. So you can see all of the energy values here. Now this is going to be reflecting on 1 mole. So if you use 1 mole of hydrogen, that means you're going to release this many moles of energy. This is why it's really confusing, because when you write it in a thermochem equation, it's got to be based on the balanced equation. When you're given these values here, it's literally kilojoules per mole. So whatever the ratio ends up being, when you balance out the equation, you have to make sure that the enthalpy that you write reflects that. So thermochem equations show energy changes. It reflects the mole ratios. The positive value of the enthalpy means that it's endothermic. If it's a negative value, it means it's exothermic. And the data book will tell you all of the values that you need to know. So this is meant to be just a primer. What we'll do in some subsequent lessons is actually build upon this, all right? And so start doing some calculations and start really understanding what all of this really means. So always remember, no matter what anybody says,